I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss polynomial functions characteristics. We'll take cubic and quartic functions to find end behavior, domain and range, x-intercepts, y-intercepts, discuss transformations, and then graph each functions. Our approach, engaging minds, help us to perform much better. We can now connect to context, visualize strategy, apply learnings, and bridge the gaps. Engaging minds help in creative thinking and problem solving. Gain the confidence. Get ready for future. We develop both mathematical and social skills. I can be part of your success story. Build strong foundation and ensure bright future. That is the gift of education. You can always contact me on the email address given. Join my classes. Now let us enjoy the lesson with Abhinav. Hi Abhinav, how are you doing?
I'm good. How are you?
Very good, very good. So today, what do you want to learn?
About cubic functions.
Cubic functions. So can you share with me what exactly you are doing in cubic functions? I'll take it
Yeah.
from you.
Okay, can you see it?
Yes, I can. Okay, great. So you have a cubic function minus 2x plus 1 whole cube plus 1, and you need to find all these points, and you need to graph it and get the critical points on this particular graph. Correct.
Yeah.
So let's begin from here itself. So you understand what the cubic functions are, right?
Yeah.
Great. So I'd like you to answer the question, and wherever there is a doubt, I'll try to guide you. So we have this equation, which is y equals to minus 2 x plus 1 whole cube plus 1. Yes, tell me, point of inflection. That is first thing you want to find.
Yeah. Negative 1 comma 1.
Negative 1 comma 1 is absolutely correct because there is a translation, 1 unit to the left and 1 unit above, right?
Yeah.
Y-intercept.
Uh,
We
negative 1.
Yes, we can calculate. So y-intercept means x equals to 0, right? So substitute x equals to 0. So you get y equals to minus 2, 0 plus 1 whole cube plus 1, right? That means minus 2 plus 1, which is minus 1, right? So you get y-intercept as minus 1. Correct. So let me write this as 0 minus 1, okay? X-intercept, how will you find the x-intercept?
You have to set y equal to 0.
Right, so calculate. So y equals to 0 minus 2 x plus 1 whole cube plus 1. So we get 2 times x plus 1 whole cube equals to 1. That gives you x plus 1 whole cube equals to half. We'll cube root. So we have 1 over 2 cube root. And x is equals to 1 over cube root of 2 minus 1. Correct?
Yeah.
You can find this value using calculator to get the answer. So what do you get? So I'm just writing a whole number here, which is cube root of 2 in the denominator, and we have 1 minus cube root of 2. So there is one x-intercept. What value do you get?
I don't have a calculator with me right
Oh, you don't have it. Oh, we'll just keep it a whole number. Don't worry. Okay, so this can be calculated. So what is the range?
now. Negative infinity to infinity.
What is the domain?
Negative infinity to infinity.
All the cubic functions will have domain and range, no restrictions at all, increasing or decreasing? What do you say?
Both?
No. The cubic functions will be either in this case, because you see, if you look at the cubic function, let me sketch -2, means it is going downwards, right? Right
Yeah.
side is down. You know
Yeah.
the vertex. So the graph of this function is kind of like this. You understand? It is going from quadrant 2 to quadrant 4.
Yeah.
So you can see all throughout it is actually decreasing. So it is never increasing, right? So increasing, none,
Yeah.
never. And decreasing from minus infinity to infinity, right?
Yeah.
Now you have to figure out where is it positive. And clearly you found the x-intercept, right? Which is 1 over cube root of 2 minus 1. And you also know that the point of inflection is at minus 1, 1, right? So this point of inflection was at minus 1, 1, correct?
Yeah.
So basically think like this. Y-intercept is at minus 1, right? So y-intercept is at minus 1. And we know, so somewhere here, I mean, y-intercept, this is, sorry. So we don't know, we have this point which is on, so 1 over cube root of 2 minus 1 is going to be negative, correct?
Yeah.
So it is positive on the left side of x-intercept, right?
Yeah.
So basically, if you put the points on the graph, let me just put them, it'd be better for us. Point of inflection minus 1, 1. So minus 1, 1, that is the point of inflection, right? And
Yeah.
then we have y-intercept is at 0, minus 1, right? So somewhere we have this graph. So basically, I mean, I'm sketching a rough graph here. And what are we looking at? We're looking at this x-intercept, right? I
Yeah.
mean, this x-intercept is here. Let me just do it. Because we wrote it up. This x-intercept we are looking at, right? So it is
Yeah.
positive here and negative. Therefore, the positive will be from minus infinity to, you can write down 1 over cube root of 2 minus 1.
Okay.
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 And it is negative from 1 over cube root of 2 minus 1 to infinity on the right side of this x-intercept. Perfect.
Yeah.
Explain the right end behavior, please.
Okay. As x goes towards infinity, y goes towards negative infinity, and as x goes towards negative infinity, y goes towards infinity.
Perfect. Transformations.
Okay. Reflect over the x-axis, translated right one, translated left one, and translated up one.
You are right. So that is how we are going to do it. The graph is right before you. It will look something like this, right? Yes. Okay. Where the critical points can be easily sketched. You can also plot some more points here to get accurate graph. Okay.
Okay.
Is that clear to you?
Yeah.
Let's move on to the next question. So y equals to 3 minus x whole cube. Tell me about this graph, point of inflection.
1, 0.
Point of inflection. So it is, we are given the equation y equals to 3 minus x whole cube. Is it okay? It is a
Yeah.
good idea to factor out the negative thing, right? So when you factor out, it comes outside. Is that clear to you?
Yeah.
And what you get here is, because minus 1 cube is, so you get x minus 3 whole cube. Is that clear to you?
Yeah.
So we could write it like this. Sometimes you may also write like this. Within square brackets, minus outside x minus 3 whole cube. So these are two ways you could write your equation.
Okay.
Accordingly, there is a major change here. If I write minus outside, then in transformations, I'm saying reflected on the x-axis. But if I write inside, I'm saying reflected on the y-axis. You get the idea?
Yeah.
Now, let us say the question is given to us in this given form. So I will prefer to put this as my base minus inside. So now I will say that the function is reflected on the y-axis. You get the idea?
Yeah.
On the y-axis. But either way, the graph is going to be similar. Negative means that the graph is going to be like this. You get the idea?
Yeah.
More or less. That is the graph. Now we have to figure out all other points. But based on this, we can answer the questions. So first, in point of inflection is what?
3, 0.
Perfect. Y-intercept.
Uh,
X0, 3 cube, right?
27.
X-intercept. So you put 0 equals to 3 minus x whole cube.
Yeah.
Perfect. So 0 equals to 3 minus x equals to 3, right? So x-intercept is at 3. Is that clear?
Yeah.
As far as domain range is concerned, minus infinity to plus infinity, no problems.
Yeah.
Increasing, decreasing, it is always decreasing, right? So none. It is never increasing. It is decreasing from minus infinity to infinity. And when is it positive? Well, you have to find the x-intercepts, right? To look
Yeah.
into when is it positive. So it is positive if this is the x-intercept, which is at 3, right?
Yeah.
So it is positive from minus infinity to 3 and negative from 3 to infinity, correct?
Yeah.
And behavior similar to what was in the last question, x approaches negative infinity, y approaches positive infinity, right? And when x approaches positive infinity, y approaches negative infinity. Is it clear to you?
Yeah.
Transformations, yeah, tell me. Transformations, we'll use this equation for transformation, right? We'll say reflection on
X.
y-axis
Y.
because we'll treat this as inside. You get the idea?
Yeah.
So I'll prefer you to write down this equation into that form and then describe the transformation. Is that clear to you?
Yeah.
And translate what?
Right 3 units.
Correct. Perfect. That is how we're going to answer this particular question. Is it absolutely clear?
Yeah.
Let's move on. Take up the next question, please. Okay, so quickly, can you answer all the questions?
Okay. So the inflection point is 3, comma 2.
Yes.
The x-intercept is the cube root of -4 plus 3.
Yeah, very good. So minus 4 cube root plus 3. Correct. So x-intercept is cube root of minus 4. That, what do you get? Uh, cube root of minus 4 plus 3, right? So that is a number which is less than, so it is definitely positive, right?
Yeah.
So somewhere on this side. So we have an x-intercept at this point, right? Y value being 0. Y-intercept.
0, comma negative 11.5.
Oh no, when you put 0 for x, yeah, 0 for x, you calculate it, okay. So 27 over 2, half of 27 plus 2, right?
Yeah.
Okay, how much you get?
Negative 11.5.
Okay, so minus 27. Okay, that's fine. And domain, is all real numbers.
Yeah.
Range, all real numbers. So this function is always increasing, right? So this function will be like this. Is it okay?
Yeah.
Right. And the point of inflection we just identified as 3, 2. The x-intercept is positive, uh, 0, 3. Y-intercept is at minus 11.5, somewhere here, right?
Yeah.
Right. The x-intercept is x-intercept is point plus 3, right?
Yeah.
But less than plus 3, somewhere here, right? Somewhere here. So I could actually roughly graph it like this. And that's my y-intercept. Is that clear to you? Or I've sketched the graph, right?
Yeah.
Correct. So this point here is, that's right. This point here is cube root of minus 4 plus 3, x-intercept. So that will help us to define positive and negative regions, correct? So it is
Yeah.
always increasing from minus infinity to plus infinity, decreasing none, never, positive after the x-intercept, right? So you can write 3 minus cube root of 4 minus 4.
Okay.
So uh, cube root minus cube root plus 3. So 3 minus cube root of 4. Cube root of 4 you can write. 3 minus cube root of 4. Is it okay? It's better to
Okay.
write 3 minus cube root of 4. Then we know it's slightly on the left side. Negative between minus infinity to the x-intercept, which is, let me write 3 minus cube root of 4. That is better. Because minus 4, let's be clear, minus 4 cube root is same as minus of cube root of 4, correct?
Yeah.
That is why we are writing this as 3 minus this. So it is on the left side, right? So this is 3 minus cube root of 4. Good. Okay. So end behavior, you know very clearly. Can you tell me x approaches infinity or minus infinity? What happens to y?
Negative infinity.
Correct. So, and this is positive. Correct. Graph is there, transformations. Yes, please tell me transformations.
Vertical compression by 1/2.
This is a factor of
Okay.
1/2, correct? Then
Right. Right 3 units and up 2 units.
translate 3 right, 2 units up, right.
Yeah.
Perfect, perfect. So that is how you're going to do. And you can sketch this graph. That should be fine. Now to sketch the graph, you can take, because the numbers are small, so you can take like this is 1 division, this is 2 division, right? Not necessarily making 1 as 1, right? You
Yeah.
can broaden the thing. Okay, clear. Please continue. So similar question, but this time, yeah, this time we have minus 3, 4 minus. So please tell me, this is slightly different. So how will you write transformation of this function? Y goes to minus 3, 4 minus 5, x whole cube plus 2. Yeah, tell me. We'll begin with transformation this time. Is it okay?
Okay.
Right. So tell me the transformation.
So it's reflect over x-axis,
Yes, minus 3 is outside. Reflect over x-axis.
and then reflect over y because you have to factor out the -5.
Yeah, factor out right one first, which I'm doing, right? So you get what? 4 over 5. Correct. So reflect over x-axis, reflect over y-axis, and then what is the translation?
Calculated right 4/5 and up 2 units.
4/5 units, right? That you get because you factored. Otherwise, you would have got wrong answer and 2
Yeah.
units up. Perfect. So that becomes the transformation for us. And important thing here to understand is that we need to factor. Note, factor for correct translation. Basically, horizontal translation. Correct. Now we know what is the point of inflection. Can you tell me that?
4/5, comma 2.
Perfect. And how will you find the x-intercept? Let's
So
calculate. So
so cube root of 2/3 minus 4 all over -5.
okay, so you've already done the calculation. Very good. 5 4 minus 5 over 4x, right? So I have to do x here. So what did you get?
I got cube root of 2/3 minus 4 all over -5.
Or no, we'll have to recalculate. Wait. Let me check. Okay. So what we have here is let's read it from here. So we have 3. It is better to use this form of the equation. Minus 5 x minus 4 over 5 q equals to 2, right? So we get 2 over 3. So minus 5 times x minus 4 over 5 equals to 2 over 3. And we are going to cube root this. Then you have to take 5 on the other side with a negative thing. So x minus 4 over 5 equals to negative 1 over 5 times cube root of 2 over 3. And then you have to add 4 over 5. So we have the x-intercept, which is 4 over 5 minus 1/5 of cube root of 2 over 3, correct?
Yeah.
So that
So I
becomes,
just
yeah,
I just wrote that as cube root of 2/3 minus 4, and I divided all of that by -5.
that is correct. Yes, because 5 is a common denominator. You are right. You are right. So you could do that using the initial equation itself, this equation itself, right?
Yeah.
That is correct. So you get the same. So this is slightly tricky, but I hope that is absolutely correct. Okay, now you can write rest of the things, right? Increasing. Once you get this x-intercept, you know where it is increasing and where it is decreasing, correct?
Yeah.
How will this graph look like?
It's gonna be decreasing.
Because if you see these points, then it tells you, let us look at the graph. Normal graph will be going up, right? We have to reflect this. So if you reflect this on the y-axis, then, I mean, x-axis, let us do first, then it becomes like this. But back to y-axis, it becomes similar to where it was. You get the idea?
Yeah.
So it will always be increasing.
Okay.
So it is always increasing. So these two reflections, they kind of cancel away. So if I take away this minus outside, as you can see, it makes it positive. So basically, it nullifies both the reflections, one on the x-axis and other on the y-axis. You get the idea?
Yeah.
So you can look at, so when both the reflections are involved, then the graph basically remains as parent graph itself, as far as the behavior of increasing or decreasing is concerned. Is it okay?
Yeah.
So the graph will be in this fashion, where you have identified all the points which will help you uh, sketch it properly. Clear?
Yeah.
Perfect. So we'll move on, but that was good. Do you have more questions on this?
Oh no.
Great. So that is how you will actually do cubic equations, but you could do similar things with quartic also, because these are polynomials where we do the same things, correct? Let
Yeah.
me change this equation a bit. So let's take a whiteboard now. So you
Okay.
can stop sharing. I'll take a whiteboard. We'll now look into some equation. Let's say y equals to, let's say, half x minus 3 to the power of 4, right? And we have here minus, let us say, uh, minus 8. Minus 8. Now, in this particular equation, can you tell me what is going to be the behavior of this equation? What is the turning point? What are the x-intercepts? How will you find all that? Tell me.
Okay, so the turning point would be 3 comma negative 8, right?
So the vertex will be 3 comma negative 8. Absolutely correct. And what is the y-intercept?
Uh, negative 3.5.
So you can calculate this value, because if you put x equals to 0, so negative 3 to the power of 4, right, which is 81. So half of 81 minus 8. Is it okay?
Yeah.
So 40.5 or 48, and then take away 8 from it, correct?
Okay.
31.5. So you have the y-intercept. How will you find the x-intercept?
You set y equal to 0.
Let's calculate. 0 equals to half x minus 3 to the power of 4 minus 8. So let's calculate. 8 equals to half x minus 3 to the power of 4. 16 equals to x minus 3 to the power of 4. So fourth root of 16, correct?
Yeah.
X minus 3. Now when you do fourth root of 16, what do you get?
2.
2. So both plus and minus 2 will work for you, right?
Yeah.
And from
Wow.
here, we get two values, which is x equals to 3 plus and minus 2. And that gives you two x-intercepts, which are 5 and 1, correct?
Wait, why would it be plus or minus? Because
Because,
we didn't do plus or minus for cube root.
correct. So look here. When you have a cube root of, let's address this question. Cube function is always increasing, right? Do you see that?
Yeah.
So and it is one-to-one function. Cube root of, let's say, minus 8 is minus 2, right? Cube root of 8 is 2, correct?
Yeah.
Now think about the function which is quadratic in nature, which is like this. Now, if I'm drawing a line here and trying to find these 2 points because of the symmetry, we get two values, right? Do you get the idea?
Yeah.
So let's say this point is 4. So you get y equals to, I mean, I should not say y. Y is 4 means x squared equals to 4, right? So x value could be plus and minus 2, right? So x is equals to plus minus square root of 4, which is plus minus 2, correct?
Yeah.
Same is the case with quartic function. So quartic function in this particular case can be graphed as something like this. Do you see that? The
Yeah.
vertex will be flatter than what you have in parabola. And this
Yeah.
point here is given to you as 3 minus 8.
Okay.
Since this is given to you as 3 minus 8, now when I'm saying that what are the x-intercepts, so so somewhere there will be your x-axis. And on the x-axis, you see there are 2 points where it is cutting.
Yeah.
These 2 points are as calculated the values as uh, 5 and 1. So this is at 1 and this is at 5. Do you see that? Does it make
Yeah.
sense? So that
Yeah.
is how the graph is going to look like.
Okay.
So when you have even degree polynomial, there are cases where there can be one solution, there can be two solution, or no solution at all, right? So let me, based on this, ask you another question. So let me clear the screen. And now we have another equation, y equals to, let us say this time we have 2x plus, let's say 3 whole square. Uh, let's take minus k, correct?
Yeah.
I don't know what k is. But let me put this x to the power of 4. Let's put it x to the power of 4. I mean x plus 3 to the power of 4. Now the question is, for what value of k will there be no solution? So what will you say? For what value of k will there be no solution? Part 1. Part 2, one solution. And 3, two solutions. So how will you figure this out? Without doing calculations, can you tell me the answer?
I think for no solution, k has to be negative.
Minus k I wrote, right?
Yeah.
So I wrote minus. So
Oh,
you
okay.
know the vertex, you can see the vertex, right? Vertex is at minus 3 and minus k, correct?
Yeah.
Vertex is at minus 3 minus k. Now, to have one solution, the vertex should be on the x-axis, correct?
Yeah.
So, and this parabola is opening up because this is positive, right? Or the quartic function opens up, right? That is the end behavior. When x approaches positive or negative infinity, y approaches positive infinity, right?
Yeah.
Because the leading coefficient is positive, so it's going upwards.
Yeah.
Now, if I have a function going upward, then it really depends. And we know at minus 3, we have the vertex, right? So basically, it means that the function could be either like this, right? Or could be like this, or could be like this. So these are the three cases. If k equals to 0, then we have only one solution, correct?
Yeah.
Now, if k is a positive value, because it is minus k, then that is the value. Is it okay?
Yeah.
Vertex. So if k is positive, we have two solutions. So if k is greater than 0, we have two solutions, correct?
Yeah.
And if k is less than 0, then that becomes positive, right? And it will
Yeah.
open up without crossing the x-axis.
Well, if k is greater than 0, it would have no solutions, right?
Yes, no solution because it is vertex is above the x-axis and the graph goes above that, right?
Okay.
It has absolute minimum. at this vertex, correct? So we know this vertex is absolute minimum here. Since vertex is absolute minimum, we can find the values of k for which we could have one x-intercept, no x-intercept, or more. You get the idea?
Yeah.
Okay. So that is how we could actually look into the graphs of these functions. And basically, in this, they are like kind of a vertex form, right? We give you the turning point or the point of inflection, right? So
Yeah.
what we learned here is that we learned two kinds of I mean, the function could be odd degree or even degree. So we are looking into the equation of the form y equals to a x minus p to the power of n plus q. We are looking into this particular form, right? Basically,
Yeah.
here also, we're looking into this particular form x minus p to the power of n plus q. Now, if it is odd degree function, in that case, the graph will be kind of like this. And if it is even degree function, then the graph will be this. So from here, you can always find domain and range. For a degree 4, we know that the range will be restricted based on the turning point. So two key parameters which we look into are point of inflection, and this is turning point. Values of both these points is actually PQ. You see that?
Yeah.
And some common characteristics, as you can see, here we'll have decreasing and increasing interval. Here we have only one, right? So graph is only increasing or only decreasing, right? Depending on the values of a and x, correct? So
Yeah.
here we are assuming for the graph that a is greater than 0 for both the graph. Then you have this graph, no reflection, right?
Yeah.
So you can summarize saying that for an even degree function, you could have more than one x-intercept. So now one thing is very clear here, and that is only one x-intercept. Now here, x-intercept could be, we have three conditions, right? None, one, or two. So that is one difference between odd and degree and even degree graphs which we have seen. Another difference which we have seen is increasing decreasing interval. So it is only increasing or it could be decreasing, right? Correct? In this case, we find that it has both intervals, right?
Yeah.
And decreasing. And another key difference which we notice is here range is from minus infinity to plus infinity. And in this case, the range, if it is opening upwards, in that case, the range is basically from the lowest point, which is q, right,
Yeah.
to infinity, where q is included. We are assuming a greater than 0 when graph opens up, right?
Yeah.
Of course, when it is reflected, these things will change and reverse.
Yeah.
So I think we can conclude our lesson today at this particular stage of polynomials. So, uh, Abhinav, can you describe what have you learned about polynomials so far?
Okay. So we learned about cubic functions today and the different properties of them. And then we explored the differences and similarities of the characteristics of functions with odd degrees and even degree and how their graphs look like.
Correct. Correct. So, as far as today's lesson is concerned, we looked into major details of a cubic function, which is either always increasing or always decreasing, whose domain and range are all real numbers. There is no restriction. There's always only one x-intercept. The graph has to cross through the x-axis since it goes diagonally, either from quadrant 3 to 1, or when the leading coefficient is negative, it comes from 2 to 4. However, we saw that in quartic functions or even degree functions, since we have an absolute value at the turning point, which happens to be a minimum if it opens up, a maximum when it opens downwards. And that gives you the restrictions on the range.
Yeah.
And in even degree polynomials, we also notice that the number of x-intercepts could be from 2 to 1 to none, correct? Depending
Yeah.
on in which direction it opens and where is the vertex. So the key there is that if both the signs are of the same sign, both positive or both negative, then no x-intercept. You get the idea?
Yeah.
So and if let me just again show that on a whiteboard, when there will not be any x-intercept. So if I have y equals to a and we have x minus p, let me write to the power of n plus q, where we are saying n is even degree. In that case, if a and q, if product of a and q is greater than 0, that means they are same sign, right?
Yeah.
In that case, how many zeros will you have? Tell me. How many x-intercepts?
2.
No x-intercept.
Right.
Because both are positive, right? So it is like the axis is like this and the graph is kind of like this. You understand?
Yeah.
However, if the product of A and Q is 0, that means Q is 0, right?
Yeah.
In that case, we have one x-intercept. And now, if the product of A and Q is less than 0, that means negative, right?
Yeah.
In that case, we get two x-intercepts. Is that clear to you?
Yeah.
So that is how we are going to describe the behavior of an even degree polynomial. So even degree polynomial might have 0, 1, or 2 x-intercepts, or degree will have only one, correct? And also you can
Yeah.
see, since there is a turning point, right? There is a turning point. And therefore, we have both increasing interval and decreasing interval. Is that clear?
Yeah.
So that is the summary of these types of polynomials. So I hope this concept is absolutely clear. We'll end our class at this stage. If you have any questions, you can send me a WhatsApp or a message, okay? And
Okay.
keep sharing.
Okay.
Okay, then. Have a great day. Bye. Thank you.
Okay.